Cordial saludo, estudiantes. En esta oportunidad vamos a explicar el sistema operativo ROS, Robot Operation System. Es básicamente un sistema operativo desarrollado especialmente para el control y manejo de robots. Mediante él vamos a trabajar con brazos robóticos, robots de 4 ruedas, 2 ruedas, en fin, cualquier tipo de sistema robótico, drones, en fin. En esta primera sesión vamos a compartir un video de la empresa ROS y posteriormente empezaremos a desarrollar varios experimentos y espero me sigan. Muchas gracias.
Hi, and welcome to this introductory video entitled What is ROS? ROS stands for Robot Operating System, an open-source programming framework for robotics whose development began in the late 2000s at Stanford University and Willow Garage. ROS is an important development in the field of robotics, which has been dramatically growing in popularity all over the world. It is applicable to a wide number of robotic systems, including mobile, industrial, and flying robots. To better understand ROS and its benefits, let's consider how robotic projects were developed before ROS existed. The kinds of commercially available robotics that we commonly associate with automobile factories and have seen move into different industries have historically involved software control systems that were proprietary and highly specialized for their intended tasks. Each system was different, lacked standardization, and as a result suffered from long development times. Building robots has traditionally been difficult because robot developers, in essence, had to reinvent the wheel with each new project. ROS changed this by creating a framework for developing robotic software that facilitates and even encourages the sharing and reuse of good ideas about how to control robots. Now, this has not been a trivial challenge. For one thing, different robots are designed to perform different tasks in different environments. It's hard to have one general-purpose software programming framework that will solve all the problems you will encounter as a robotics developer. However, ROS has maximized the utility of having open-source robotic software by addressing many of the common problems robotic developers face. Challenges such as coordinate system transformations, motion planning, communications, and sensor integration have field-tested ROS solutions available and ready to plug in. A programmer only has to download the appropriate software packages, include them as part of his robot design, and take advantage of the ROS community's knowledge and years of experience. And because it's open source, it's free for private or commercial use. From a practical standpoint, we can look at ROS as having 5 different facets. As we just described, ROS enables modular software development by providing a library of reusable code packages that are free and available for your use. This makes robot development much easier, faster, and reliable than if you had to develop all of your robot's capabilities yourself. ROS also provides a runtime environment that supports near real-time communication between system elements and data sharing. Although ROS is not a strict standard in the sense of ISO, HTML, or any of the other standards you may be familiar with, it does provide some conventions useful for creating and using ROS-supported code in a repeatable and reliable way. There is also a suite of ROS development tools that are helpful in monitoring, troubleshooting, and visualizing your robot. This includes building computer simulations of robotic systems to help tune a robot's behavior before you actually build it. Last but not least, there's a vibrant community of tens of thousands of users and contributors all over the world that has grown very quickly. The number of robots employing ROS has also seen dramatic growth, as can be seen here over a short 4-year period. In addition to ROS, there are other complementary open-source technologies that can be integrated as part of a comprehensive robotic control system. These include, but are not limited to, MoveIt, an open-source software for performing motion planning, including the manipulation of objects and navigation within a 3D environment. Gazebo, a high-quality physics engine that allows you to perform visual simulations of one or more robots in real-world environments. OpenCV, an open-source library supporting computer vision useful for collecting and analyzing real-time video. Microsoft's .NET Micro Framework, an open-source desktop platform for creating applications on board and chip-level devices. Feel free to visit the ROS.org website to learn more about this important development in robotics technology. There, you'll find more information about ROS, and you will be able to obtain publicly accessible software downloads, read detailed technical documentation, and visit the answers.ros.org forum, where you can find the answers to your nagging technical ROS questions. Also visit the Open Source Robotics Foundation and Willow Garage websites to get a deeper understanding of ROS history, community, and ongoing development efforts and resources.